In this video, I'm going to go over how to maximize revenue, the maximization of revenue functions. First, let's remember that R of X, revenue, is equal to the price that you can charge times the number you can sell. So we're going to be using that basic model, but then we're going to have to add some things to that. So let's say we have this situation where we have got a person or an event can charge a certain amount of money, and they're selling tickets to a concert, and from past research they know if they charge $20 per ticket they will have 500 attendees, and for every $2 increase in the ticket price they'll lose 10 people. 10 fewer people will attend. So what should they make the price for maximization of their revenue? All right, so what price should they raise it to? $22, $24, $26? Should they lower it from 20 to 18, 16, and so on in order to make the most revenue? Remembering revenue, R of X, is equal to your price times the number sold. So we need to figure out what price to charge, and we'll also then know how many we're going to end up selling, because we know we lose 10 people for every $2 increase. So that's the information. Let's see how we set this up. So what I recommend doing when you're having to do a max revenue problem is to set up the way I'm doing right now. It's kind of a formula, the way you do it every time. So you're going to have two parentheses. In the first parentheses, write the given price, whatever they say the starting price is, any price they mention, such as a company can charge $20, whatever. So put that, the parentheses, then we're going to write the given price, and then we either going if we're adding money, if we're going to raise the price, it's going to be a plus, and if we're going to lower the price to get more customers, it'll be a minus. Okay, so either plus or minus in there, and then the second part here is going to be whatever you can raise or lower the price by. Okay, in other words, is it for every $2.50 price range, or is it for every $2 rise in the price? You're going to write the dollar amount right there, and then write X. Okay, and X is going to stand for the number of price adjustments. Okay, so let's say you could go. They say if you could go every time you go up by $2. You can you're going to lose 10 people, all right? And let's say you ended up raising it by $6 in the end. That means you did 3 price adjustments, okay? But for right now, we're putting an X there because we haven't decided how many times we need to raise or lower the price. So given price, if either plus or minus, depending if you're adding to the price or taking off, and then the dollar amount for each change in price, and then X. Now our second parentheses, we're going to start with the given number. So for instance, they say the company can sell 400 pieces of product, and the theater can sell 200 tickets. Whatever is the given amount in the information they give you, put that number right there. Then, again, we're going to either have a plus or minus depending on whether, are we going to gain people for every time we lower the price? Are we going to lose people every time we raise the price? And so these will always be opposite. If you have a plus up here because you're adding to the price, you're going to have a minus down here because people aren't going to want to pay that. But however, if you have a minus up here because you're taking away the price, or you're lowering the price, then you will end up adding people. So these always need to be opposite each other. Okay, and just like here where I had the dollar amount per price change times X, here I'm going to write the number people gained or lost, whatever it be, the number of them, X, then the X. So let's say you would gain, or you'd lose 10 people every time you raise the price. Then you're going to want to put minus 10x, okay? Minus 10 people times x. And again, what is x? X is our number of price adjustments. All right, so in the situation right here, if we know that, let's say the company says that they can charge, they charge $10. That's what they said. It says they can charge, or sorry, $20 they can charge and they will get 500 people. Okay, so we're going to start off with the given price. Okay, it was $20, and then they're going to raise it by $2 a certain number of times. So for every $2 price raise, so $2 per X, meaning price adjustments. $2 per price adjustment. Okay, that's my first parentheses. My second parentheses I said here is the given number that they give right away that they can sell. So in this situation, it was 500 was the given amount at the beginning that they could actually sell. And again, because we're adding to the price, because this is a plus here, then we're going to end up with a subtraction because we're losing people. And how many people are we losing? 10 fewer people. Again, every time the price is adjusted. So X, 10 people for every time we raise the price by $2. Right now, I have the function that I can graph, and this is a revenue function, okay, what I have up here, and you don't even need to multiply it out because you can just type that into your calculator and get the graph. And again, we're looking for the maximum revenue. So you're going to get an upside down parabola, and it's going to look something like this, and then you're going to look for the vertex. Okay, so what do we do with the vertex? Well, I'll show you let's plug this into Desmos, and you can see what it looks like for this situation. So since on the vertex X is equal to 20, we're going to do 20 price adjustments of $2. And this first parentheses, remember, this is our price that we're going to charge. We have the 20 already there, plus 2 times X. So X at the vertex is 20. So we're going to go 2 times that 20. So this comes out to be $60. That is going to be our price. The second parentheses up here, this represented the number that we'll end up selling. Again, we're going to use X as 20. 500 minus 10 times 20. So again, X is 20. That is 20. Notice I'm not paying attention to that 18,000 for the Y coordinate yet. We're using X equals 20, using X coordinate for both of these parentheses up here, for the price and then for the number sold. So the number sold is going to be, we had the 500. Now we're doing minus 10 times 20, so minus 200. That means you're going to have 300 tickets sold. $60 price, that's the price of the ticket we need to have, and then we're going to sell 300. Okay, so usually the question will ask you what is the price that you have to set it at to get the maximum revenue. So this you would answer $60. They don't usually ask you then, okay, how many will you sell? But if they did, you say, I'll sell 300. They also will ask you, okay, what would be the maximum revenue? What would the revenue come out to be? That is the Y coordinate. Remember, because what we're doing here, that Y-axis, that's really the revenue. Because this function up here that we're doing, this is really equal to the revenue. So our Y coordinate, the 18,000, is the revenue, $18,000, when we use 20 for X, when we increase the price or adjust it 20 times. So the revenue, max revenue you would get is the $18,000. So that's how you do these maximization of revenue problems. And so once you get how to set up the original function for the revenue, the rest is pretty easy. It's just graphing and finding the vertex.